Have you ever stopped to think about what really happens in the heart of the Sun, the star that lights up our lives every day? The solar core is one of the most mysterious and fascinating places in the universe, where nuclear processes occur that defy our understanding and fuel the energy that sustains life on Earth. In this video, we will explore the secrets hidden thousands of kilometers below the solar surface and discover how these incredible processes influence everything around us. Imagine being able to uncover the inner workings of a natural nuclear reactor, where unimaginable temperatures and extreme pressures transform hydrogen into helium, releasing energy on a colossal scale. How do these phenomena affect our planet? And what do they tell us about the future of nuclear energy here on Earth? Get ready for a journey to the center of the Sun, where science and technology meet to reveal the mysteries of the universe. Stay with us until the end and let yourself be fascinated by this incredible journey into the heart of our star. The Sun, a colossal sphere of incandescent plasma, serves as the ultimate source of energy for our planet. Its influence is omnipresent, from the warmth that nurtures life to the light that fuels photosynthesis in plants. But beyond its surface, the Sun harbors a core that is both the engine and the enigma of this celestial body. Understanding the core is crucial, as it is here that the Sun's immense energy is generated. Nestled within the Sun's center, the core is a realm of extreme conditions. With temperatures reaching approximately 15 million degrees Celsius and pressures so high that atoms are stripped of their electrons, the core is a crucible of nuclear reactions. These conditions facilitate nuclear fusion, a process where hydrogen nuclei collide and fuse to form helium, releasing vast amounts of energy in the form of light and heat. This energy eventually makes its way to the Sun's surface and radiates into space, sustaining life on Earth and driving the climate and weather systems. The journey to understanding the core's mysteries is not just a scientific endeavor, it is a quest that promises to deepen our comprehension of the universe itself. By studying the core, scientists aim to unlock the secrets of stellar evolution and the life cycles of stars. As we delve into the core's complex processes, we begin to see how interconnected our existence is with this distant, yet vital, celestial powerhouse. This understanding sets the stage for our next exploration, the intricate structure of the Sun and how each layer, particularly the core, plays a pivotal role in the grand cosmic ballet. Let's dive deeper into the Sun's anatomy and uncover the secrets that lie beneath its fiery exterior. To truly appreciate the mysteries of the Sun's core, it's essential to understand the Sun's overall structure. The Sun is composed of several layers, each with distinct characteristics and functions that contribute to its overall behavior and energy dynamics. From the outermost layer to the core, each plays a crucial role in the life of our star. Starting from the outside, the Sun's atmosphere consists of the corona, chromosphere, and photosphere. The corona, visible during solar eclipses as a halo of plasma, extends millions of kilometers into space and is surprisingly hotter than the surface below. The chromosphere lies beneath the corona, a region where solar flares and prominences originate, displaying the Sun's dynamic activity. The photosphere is the visible surface of the Sun, where sunspots and granules can be observed, and is the source of the sunlight that reaches Earth. Beneath the photosphere lies the convective zone, a turbulent region where hot plasma rises, cools, and sinks in convection currents, similar to boiling water. This movement helps transport energy outward from the core. Below the convective zone is the radiative zone, where energy generated by nuclear fusion in the core is transferred outward via radiation. In this dense region, photons can take thousands of years to travel through due to the high density of particles. At the heart of this stellar structure is the core, the powerhouse of the Sun occupying about 25% of the Sun's radius. The core is where nuclear fusion occurs. Hydrogen atoms are compressed and heated to such an extent that they overcome their natural repulsion and fuse into helium, releasing energy in the process. This fusion process not only powers the sun but also creates the light and heat that make life on Earth possible. Understanding the sun's structure is crucial as it provides insight into how energy is generated and transported within the star. Each layer, from the surface to the core, is integral to the sun's function and stability. As we move forward, we will delve deeper into the fascinating processes occurring in the core, where the true magic of nuclear fusion takes place, powering our solar system. At the very heart of the sun lies the core, a region of incredible pressure and temperature, where nuclear fusion occurs. This process is the engine of the sun, converting mass into energy and sustaining the star's luminosity and heat. Understanding these processes not only fascinates us but also provides insights into the fundamental workings of the universe. Nuclear fusion in the sun's core primarily involves the fusion of hydrogen atoms into helium. This process occurs through the proton-proton chain reaction, the dominant fusion pathway in stars like our Sun. In this reaction, two protons collide with enough force to overcome their mutual electrostatic repulsion, facilitated by the extreme conditions of the core. This collision results in the formation of a deuterium nucleus, a positron, and a neutrino. The deuterium nucleus then fuses with another proton to create helium-3, releasing gamma radiation in the process. The chain reaction continues as two helium-3 nuclei collide to form helium-4, releasing two protons and a significant amount of energy. This energy is what we perceive as sunlight and heat, essential for life on Earth. The fusion of hydrogen into helium in the sun's core is a highly efficient process, with the energy produced being equivalent to the conversion of 4.26 million metric tons of mass into energy every second. The energy generated in the core takes a long journey to reach the sun's surface. Initially, it is absorbed and re-emitted countless times in the radiative zone, a process that can take thousands of years. Once it reaches the convective zone, it is carried upwards by the movement of plasma, eventually reaching the photosphere and radiating into space as sunlight. The conditions necessary for nuclear fusion are extreme. The core's temperature exceeds 15 million degrees Celsius, and the pressure is more than 200 billion times the atmospheric pressure at Earth's surface. These conditions are essential for overcoming the electrostatic repulsion between hydrogen nuclei, allowing them to fuse. The fusion process not only powers the sun but also creates and disperses elements throughout the universe. The energy and particles released during fusion contribute to the solar wind, influencing the solar system's environment and affecting planetary atmospheres, including Earth's. Exploring the processes in the sun's core deepens our understanding of stellar physics and the life cycle of stars. It also provides valuable insights into potential energy sources for humanity, as scientists strive to replicate fusion on Earth for clean, sustainable energy. As we continue our journey, we will examine how these core processes impact our planet and the broader cosmos, highlighting the interconnectedness of the universe. The energy produced in the sun's core through nuclear fusion not only sustains the sun itself but also has profound effects on Earth. The sunlight and heat generated are crucial for maintaining the climate, driving weather patterns, and supporting life on our planet. This energy influences every aspect of our environment, from the growth of plants to the behavior of the oceans and atmosphere. One of the most direct impacts of solar energy is on Earth's climate. The sun's radiation heats the planet, creating temperature gradients that drive atmospheric circulation. This, in turn, influences weather patterns and climatic conditions across the globe. The energy from the sun is also vital for the water cycle, powering the evaporation of water from the Earth's surface and driving precipitation. Without the sun's energy, life as we know it would not exist. In addition to its role in sustaining life, the sun's activity can also have disruptive effects. Solar flares and coronal mass ejections, which originate from the sun's surface but are driven by processes in the core, can release massive amounts of energy and charged particles into space. When these particles interact with Earth's magnetosphere, they can cause geomagnetic storms, which can disrupt satellite communications, navigation systems, and even power grids. Understanding the Sun's core and its activity is crucial for predicting and mitigating these impacts. The Sun's influence extends beyond just the physical environment. It also affects biological rhythms and behaviors. Many organisms, including humans, have evolved to synchronize their activities with the cycle of daylight and darkness, which is regulated by the Sun. The energy from the Sun drives photosynthesis in plants, forming the base of the food chain and supporting all life on Earth. As we delve deeper into the mysteries of the Sun's core, we gain a greater appreciation for the intricate connections between our star and our planet. This understanding not only enhances our knowledge of the natural world but also helps us prepare for and adapt to the Sun's dynamic influence. Next, we will explore the scientific discoveries that have illuminated our understanding of the Sun's core and its processes. The quest to understand the Sun's core has driven scientists to develop innovative technologies and methodologies, leading to groundbreaking discoveries. These advancements have not only deepened our knowledge of the Sun but also opened new avenues for exploring other stars and cosmic phenomena. One of the key tools in solar research is the Solar Observatory. Ground-based telescopes, such as those at the Mauna Loa Solar Observatory in Hawaii, and space-based instruments, like the Solar and Heliospheric Observatory, SOHO, have provided invaluable data about the Sun's behavior and structure. These observatories capture high-resolution images and spectra, allowing scientists to study solar phenomena in unprecedented detail. Helioseismology, the study of the Sun's internal oscillations, has been particularly instrumental in probing the core. By analyzing the waves that travel through the Sun, scientists can infer the internal structure and dynamics, much like seismologists use earthquake waves to study Earth's interior. This technique has revealed details about the core's temperature, composition, and rotation, enhancing our understanding of the fusion processes occurring within. Recent missions, such as the Parker Solar Probe and the Solar Orbiter, have brought us closer to the Sun than ever before. These spacecraft are equipped with instruments designed to withstand extreme conditions, capturing data from the Sun's outer atmosphere and providing insights into the solar wind and magnetic fields. These missions aim to answer fundamental questions about the Sun's activity and its impact on the solar system. One of the most intriguing discoveries is the detection of solar neutrinos, elusive particles produced during nuclear fusion in the core. Neutrino observatories, like the Super Kamiokande in Japan, have confirmed the presence of these particles, providing direct evidence of the fusion processes powering the Sun. This discovery has been crucial in validating our models of stellar physics. As we continue to explore the Sun, each discovery brings us closer to unlocking the full mysteries of its core. These scientific endeavors not only advance our knowledge of the Sun but also contribute to our broader understanding of the universe. Next, we will discuss the implications of these discoveries for the future, particularly in the context of energy and space exploration. The insights gained from studying the Sun's core have far-reaching implications, particularly in the realms of energy production and space exploration. By understanding the processes of nuclear fusion that power the Sun, scientists are inspired to replicate these reactions on Earth, potentially revolutionizing our approach to energy. Nuclear fusion holds the promise of a nearly limitless and clean energy source. Unlike nuclear fission, which splits heavy atomic nuclei, fusion combines light nuclei, such as hydrogen, to form helium, releasing vast amounts of energy in the process. This is the same reaction that occurs in the Sun's core. If harnessed effectively, fusion could provide a sustainable solution to the world's energy needs, reducing our reliance on fossil fuels and mitigating climate change. Research into fusion energy has led to the development of experimental reactors like ITER, International Thermonuclear Experimental Reactor, in France. These reactors aim to achieve self-sustaining fusion reactions, using magnetic confinement to contain the hot plasma necessary for fusion. The success of these projects could mark a significant milestone in our pursuit of clean energy, directly inspired by the processes occurring in the Sun's core. Beyond energy, our understanding of the Sun's core also has profound implications for space exploration. The study of solar physics helps us predict space weather, which is crucial for the safety of astronauts and the integrity of space missions. Solar activity, driven by core processes, can affect spacecraft electronics and pose radiation hazards. By understanding and forecasting these events, we can better protect our space assets and crewed missions. Furthermore, insights into stellar processes inform our search for life beyond Earth. By studying the Sun, we learn about the conditions necessary for life and the potential habitability of exoplanets orbiting other stars. This knowledge guides our exploration of the cosmos, helping us identify promising targets for the search for extraterrestrial life. As we continue to unravel the mysteries of the Sun's core, the knowledge we gain not only enriches our understanding of the universe but also drives technological and scientific advancements that can transform our future. In the final chapter, we will summarize the key points and reflect on the profound connection between our star and our existence. Throughout our journey into the heart of the Sun, we've uncovered the intricate processes of nuclear fusion that power our star and sustain life on Earth. From the extreme conditions in the core to the profound impacts on our planet and the broader universe, the Sun's core remains a source of endless fascination and scientific inquiry. By understanding these processes, we not only deepen our appreciation for the cosmos but also unlock potential advancements in energy and space exploration. As we continue to explore, the mysteries of the Sun's core will undoubtedly inspire future generations to reach for the stars.